Hello friends, welcome to the fifth session of maths. Today we are going to look at triangles. Before we get to triangles, let's try to understand the basic concepts of geometry, point and line. So what exactly is a point? Try to recall a definition of a point. A point is basically a position in space. So keep in mind that whenever we are talking about point, we don't necessarily talk about a two-dimensional plane. What exactly is a plane, that will come later, but most of the times in geometry, at least the basic geometry, we always associate point to be a particular location on a plane, but it is not like that. A point can be anything. It could exist anywhere in the three-dimensional world. So it's a position in space. Point has no width, no length, no breadth, so it is just a position. So for example, this is one point, this is another point, right? And if you in fact zoom this to, let's say, 1,000 times, you will see that this point will also be a collection of multiple points. So when we talk about a point in geometry, so we are talking about one individual point out of this. It does not have any width, it does not have any length, it does not have any breadth. And what exactly is a line? A line is the simple geometric figure that we get by joining 2 points, any two different points. Straight figure connecting 2 points. It is considered infinite. So when we are talking about a line joining these two, it is considered that the line can be extended on either side, and it does not end. It is infinite in length. It does not have any width. So difference between, if you want to find out the width of this, you will find that it is 0. In fact, it's like a paper being cut into 2 pieces by a line. So what would be the width of the cut? It does not have any particular width, right? So same way, the line has no width. Minimum 2 points are required to form a line. How many lines can go from 2 particular points? How many lines can we form? We can only form one particular line from 2 points. How many lines can we draw from one particular point? So let's say this is the point. How many lines can we draw? We can draw infinite number of lines. So this can be one line. Actually, it's not going through the point, but let's say this is the point. This can be another line. This can be another line. This can be another line. So you see that there are infinite number of lines we can draw from one given point. Similarly, any 2 points in space can be joined by a line. So let's look at some other basic concepts, angle and plane. So what are angles? So angles are basically degree of rotation. So when we are talking about an angle of, let's say, 30 degree. So this is a line. I'm talking about an angle of 30 degrees. So it is something like this. This is how we write it. So we write it in terms of degrees. And what we are talking about is how much we have to rotate. We are talking about an angle between these two lines. So how much does one line have to rotate to meet the other line? The one line, let's say this line, has to rotate 30 degrees to the right to meet this line, or this line has to rotate 30 degree anti-clockwise to meet this line. So this is the degree of rotation we are talking about. It is measured in degrees. The unit is degrees. So 30 degree, 90 degree, that way. So unit is degrees. Minimum 3 points are required to form an angle. So let's say minimum 2 points are required to form a line, and minimum 2 lines are required to form an angle. So that means in all we need 3 specific different points, and those 3 points, if they lie on the same line, for example, if we are talking about these 3 points, in other words, if they are collinear, if they lie on the same line, then the angle we are talking about is 180 degrees. So this is considered to be 180 degrees. This is another 180 degrees, and entire angle, all the no, this entire angle that constitutes one revolution is called 360 degrees. It is considered to be 360 degrees. Similarly, any 3 points in space can make an angle. So let's say we are talking about this, this and this. Any 3 points in space can make an angle. So here right now you are only imagining it as 3 separate points on one particular plane, the plane being the particular slide or your computer screen. But it could also be, for example, this is your computer screen, and let's say this is one point on the computer screen, second point on the computer screen, and the third point could be somewhere out of the screen, you know, for the sake of imagination. And that could be, let's say, your pen or a tip of your pen. So this is one point, second point, third point, and there will be one angle forming that. So that angle does not lie on the plane of the computer screen. So let's look at the definition of the plane itself. So what exactly is a plane? I just explained you know that this angle, that angle between 2 points on your computer screen and the third point being your tip of your pen, it does not fall in the plane of your computer screen. So what exactly is a plane? A plane would be a flat two-dimensional surface. So when we are talking about the plane of computer screen, we are talking about this surface. We are not talking about any point, or we're actually talking about the surface. Now you will see that this angle, one point on the computer screen, second point on the computer screen, and third point somewhere outside, not on the computer screen. The entire angle obviously does not fall in the plane of the computer screen. However, if you're talking about these 3 angles, let's say this and this and this, and all 3 angles lie on the same plane of computer screen, then we can say, you know, all these angles are the entire angle falls on inside the plane. In fact, if you look at it, just to make it a little more complicated, if you're talking about this angle, this angle, 2 points on computer screen and the point that is tip of your pen, that will also form a plane. A plane can be formed with any 3 angles, but that plane is not going to be the computer screen. That plane is going to be something else, right? So for the sake of understanding, the plane is a flat two-dimensional surface. Minimum 3 points are required to form a plane. How many planes can go from 2 points? Let's say these are 2 points and this is one line connecting those 2 points. How many planes can we form? We can form infinite number of planes. Now think of it like this. You have a book and all the pages are bound with respect to one particular line, right? So let's say this is your book and all the pages connect here. Now open that book and look at it in such an angle where you see, let's say this is the book binding common line, and these are individual pages, right? So every page is one particular plane, right? This is one surface, this is another surface, and this line that is binding all these pages is basically a line. I mean, if I want to draw it 3-dimensional, I'm talking about like this, right? So this is one particular line we are talking about. So that means from any given line we can have infinite number of planes, but for us to form a plane we need 3 points. Any 3 points in space can make a plane, and minimum 3 points are required. So these are really the basics of geometry. So let's move on to the actual topic of triangles. What exactly are triangles? Triangles are shapes with 3 coplanar lines. So let's say 3 coplanar lines, in the sense 3 lines that fall in the same plane. So let's say we are talking about the plane of computer screen and we have 3 lines, one line, second line and third line. Okay, so these 3 points make that plane, and these 3 lines make a shape that is bound by 3 lines, correct? So this kind of a shape is called triangle. It has 3 sides. You will see it has 3 sides, 1, 2, 3, right? It has 3 angles, 1, 2, 3. So a triangle will have 3 sides, 3 angles. Minimum 3 non-linear points are needed to form a triangle. Now what do we mean by this? Minimum 3 non-linear points. Now let's say minimum 3, obviously if you want to form a shape of 3 sides and 3 lines as their sides, we'll definitely need 3 points. But what is this restriction of non-linear points, right? Now let's say we try to join three linear points being lines on the same points on the same line. So let's say we have these 3 points, they lie on the same line, and let's try to form a triangle out of them. So what would be the first side of the triangle? It would be this, correct? What would be the second side? Second side would be this. What would be the third side? Third side is going to be this, connecting these 2 extreme points. But we'll see that the third side is basically the same as the first and the second side, because of which we do not have three different sides that will make a triangular shape. There is no shape coming out of this. So that is why there has to be a restriction that those 3 points that are joining the sides, they have to be non-linear. You cannot form a triangle from 3 collinear points, right? So this is how generally a triangle looks like. Let's move to the basic properties of triangle. Length of one side has to be less than the sum of lengths of other 2 sides and greater than the difference between other 2 sides. Otherwise the triangle is not possible. Now this looks very complicated. Let's look at what exactly it means. Length of one side has to be less than sum of lengths of other 2 sides. Okay, let's see if we break this rule. What happens if we break this rule? Okay, so we have, let's say we choose any two numbers, 2 and 6, let's say, and we try to form triangle with sides 2 and 6 and the third side being x, and let's assume that x is greater than, now what does this restriction say? It restriction says that one side has to be less than sum of the length of other 2 sides. So here the restriction says that x has to be less than 2 plus 6 equal to 8, right? And we are only looking at the first restriction. We'll also look at this second one. Okay, now let's say the rule says that x has to be less than 8. Let's assume x is not less than 8. That means either x is going to be equal to 8 or x is going to be greater than 8. Let's see if in this scenario whether we can form a triangle, correct? Okay, so let this be 6. Let's say this is 6 units long. This is one side. The second side is going to be starting from this point. It's going to be length 2. That means it could be in any direction, right? So that means basically we are talking about, let's say this is a circle of radius 2, correct? And any point is, this is the center of the circle, and any point is 2 units away. That means the radius is 2 basically. So the third point of the triangle has to lie on this circle, correct? Otherwise, so if you pick this point, we are talking about this particular triangle. If you pick this point, we are talking about this particular triangle, like this. Okay, so it could lie anywhere, right? Now let's say if it is equal to 8, if that length of the third line is going to be 8, so that means this point and this point will have to, the length between these 2 points will have to be 8. Now if you look at it, if you extend this line further, correct, so this is going to be 2 from this point, and this is the third point we are talking about. So this distance is 2, and from here to here the distance is 6. So that means this is the only line in which x can be equal to 8, correct? So if you assume x equal to 8, that is the third length, third side is equal to 8 units. So this is this will have to be the point, the third point, and you will see that these 3 points now become collinear. But the definition of triangle says that it cannot be collinear. So that means this possibility is ruled out. Correct? Why it is ruled out? Just look at it quickly. So this, if this is 6 centimeters long, and the second side is 2 centimeters long, so basically the third point of this the triangle, these are 2 points, the third point of the triangle will have to lie on this particular circle. And if x is supposed to be 8, then the third point will have to be this point, because this is 2 and this is 6. So this will have to be the third point, and then it makes these 3 points collinear, so we cannot have a triangle. So this possibility is ruled out. Let's look at other possibility where whether we can have x greater than 8, right? Okay, so let's assume that let's look at this figure itself. Okay, so this is 2, the radius of this circle is 2, and this is 6. Now we want a particular point which is going to be more than 8 centimeters away. That means let's draw a circle. Whenever you have whenever you want to find out a point which is a certain distance away from a particular point, we just draw a circle, right? So we are talking about this is one small circle we have of radius 2. This is the first point, this is the second point, and we are talking about a circle of radius 8 now, because x will have to be greater than 8, correct? So from here we draw, so this is 6, this is 2. So the circle of 8 radius 8 is going to go like this. No, obviously it's going to be much bigger, but it's going to be something like this, correct? And it is going to meet this circle at point 2 here, correct? So now we are talking about the restrictions we have here is the point has to lie on this small circle, and it should be away from this, this should be outside of this bigger circle. Now this point does not exist. This point cannot exist because this entire small circle is fit within the large circle. So it is not possible that a point lies on the small circle, but it is outside of the big circle. Now why outside? Because we are talking about x greater than 8. So the point has to lie outside the circle drawn from this point of radius 8. So we'll see that this condition also cannot hold true. So that means there we cannot have a situation where x is equal to 8 or x greater than 8. That means x has to be less than 8, which is the first condition. One side has to be less than sum of length of other two sides. Now also let's look at what is the second condition, greater than the difference between the other two sides. So let's look at again the same triangle, 2, 6 and x, 2, 6 and x, and we violate this condition, and let's see if this is possible. So what is it saying? X is greater than the difference between the other two sides. So difference between these two is 4. So x will have to be greater than 4. This is what the rule says. Now let's say I assume x is going to be equal to 4. And I will also assume that in another instance I will assume that x is less than 4, and I will try to prove that this situation exists. A triangle can exist with x is equal to 4 or x is less than 4. Okay, if it exists, then the rule doesn't make sense. If we fail to provide a triangle with these two conditions, then we'll have to accept this rule, correct? So let's look at the same thing, just that we are drawing the circle from on the other side. So we are talking about this guy, this point line segment is 6 units long, and this is the radius is 2. The radius of this circle is 2. Now we'll see that for x is equal to 4, that means if I'm talking about a point which is 4 units away from this point, so that will have to be this particular circle which is of radius 4, and you will see that both these circles will have to meet in this point. Correct? Why? Because the whole length is 6, out of which this circle is, this point is inside 2 centimeters or 2 units, and this point is inside 4 units. So 4 plus 2 is equal to 6. So both the circles will have to meet in this point, and this point is again, then we are talking about this point as first point of triangle, this as second point of triangle, this of third point of triangle, and both, all these points are collinear. So again, because they are collinear, we cannot have a triangle, so this condition is bound. Pretty much the same way, if we are talking about a point which is less than 4 centimeters away, x less than 4 from this point, then we are talking about the inside area of the triangle. Now if we are talking about inside area of the triangle, inside area does not include the outer boundary. Okay, so inside area is something that is, because we are talking about x less than 4, so inside area of the triangle and the circle of radius 2, this circle, and the area that is inside this circle, the bigger one, x is equal to 4, there cannot be any common point of intersection. That is because this ends here, whereas it can, this circle cannot extend to the right side of this line, and the area cannot go to the left side of this line, right? And it also does not, this particular point of intersection between the radius of circle 2 and radius of circle 4 is not included in x less than 4. So that means again we cannot find a point of intersection, and this triangle is not possible. By assuming that these conditions do not hold true, we try to draw two triangles, but we fail to do that, and that is why we have to accept this as a rule. So length of one side of a triangle has to be less than the sum of other two sides and greater than the difference between the other two sides. The second convention we have to remember is that the degree of angles, the sum of all angles is going to be 180 degrees. Now this is something that you have to know. This is one of the basic properties of mathematics. So if you are talking about triangle ABC, the sum of all these angles, A plus B plus C, is going to be 180 degrees. The side opposite to the greatest angles is the largest side. So this is another useful property. So if you are talking about, let's say this is a triangle, now you will see that this is the largest angle and this is the longest side. So they are always opposite. If you are talking about a very small angle, let's say like this, so look at which is the smallest angle. This is the smallest angle. This is which is the smallest side. This is the smallest side. So they are always opposite. The side opposite to the greatest angle is the largest side, and the side opposite to the smallest angle is the smallest side. Types of triangles. There are different types of triangles. They are categorized with respect to their side or angle. So now in this slide we are looking at categorization of triangles with respect to sides. Equilateral triangle are the triangles that have all the sides equal in length. So we are talking about this side, length of this side, if this is x units, this is also x units, this is also x units. Now because all the three sides are same, all the three angles are also going to be same, right? And what is the sum of all internal angles? It's 180 degree, and all the three angles are same, so each angle has to be 60 degrees. So whenever you see a 60 60 60 triangle, it's going to be an equilateral triangle. All sides are equal, and all angles are equal. Isosceles triangle are the triangles where only two sides, it could be any two sides, only two sides are equal. So here in this case we are talking about this side, length of this side is equal to length of this side. This side is the length of the base, this side is something different, right? Because these two sides are common in length, their corresponding opposite angles are also going to be equal. So we will see that these angles that correspond to the equal lines, the lines that are equal in length, they will be the same. Third type of triangle is culling triangle, in which there is no such kind of relation exists. All three sides are different, and because all three sides are different, all three angles are also different. This is not length, this is measure. Sorry for that. Okay, so let's move on to different categorization. Types of triangles by angles. We are looking at the first category, which is acute angles. So all angles that are less than 90 degrees. When we have a triangle which has all angles less than 90 degree, it's called an acute triangle. 90 degrees is perpendicular. This is how you usually rotate display 90 degrees. So 90 degree basically is exactly divides this particular line. Let's say this particular line is the original line, and we draw another line such that this angle is equal to this angle, then it's going to be 90 degrees. So that is, we call it is perpendicular, and this measure of this angle is 90 degrees. Okay, so if you don't have a 90 degree angle, or all angles are less than 90 degrees, it's called acute triangle. A right triangle is the one in which one of the angles is 90 degrees. And you see that this is perpendicular to this one, correct? Okay. There can only be one 90 degree angle because the sum of angles is 180 degree, so we cannot have two 90 degree angles. So the third angle then will become 0, which doesn't make sense. So there can only be one 90 degree angle, and the other angles are going to be less than 90 degree. In fact, their sum is also going to be 90 degrees, right? Okay. Obtuse triangle is a triangle that has one angle greater than 90 degree, like this. So these are the basic types of triangles. Some basic terms: perimeter and area of triangle. A perimeter is basically the sum of all the three sides. So if you're talking about this triangle, so you're talking about the length of this plus this plus this. Let's say if the length is A, length is B, length is C, you're talking about A plus B plus C. This is the perimeter, sum of lengths of sides. The area of a triangle, it is always half base into height. Height is the length, perpendicular length from one particular point to the side opposite to it. Let's say, for example, if this is the triangle, so what I do is, from here I draw a perpendicular on this line, the opposite side actually, and then I consider this as H. Now interestingly, if you are talking about, look at this particular kind of a triangle, an obtuse kind of a triangle. So you will say, I want to draw a perpendicular from here. It is not necessary that the perpendicular has to lie within the area of the triangle. It is also fine if the perpendicular, in this case the perpendicular is going out of the triangle, right? So this particular point is not included in the triangle itself, but that is fine. What we will consider this as the height. So keep this in mind. It can be a little confusing to for the beginners, but this is going to be the height, and the base is considered to be the base on which this perpendicular was drawn. So this perpendicular was drawn on this segment, so this is going to be the base, right? So the basic formula here is half base into height is considered to be the area of a triangle. And why do we have half base into height? Let's look at this particular triangle. This is the base, right, and this is the height, and we are saying that half base into height is the area of the triangle. So let's see. What we do is, we do a paper cutting of this triangle, and we make two such copies, and we try to fit the second copy next to the first copy like this. Okay, so what we'll get some kind of a quadrilateral. We get we don't know if it's going to be rectangle or square, but we're going to get some kind of a shape like this, right? Okay, now what we do is, we cut this, we draw a perpendicular line, and we cut this area, and we bring this area here. We try to fit it here. Then you will see that you will get a rectangle in the sense a shape with four sides, and all angles 90 degrees. So and we know that the area of the rectangle is base into height. The height is going to be this much length, and base is going to be this much length. So base into height is the area of rectangle. And how many triangles we had in this figure? We had two triangles. So and both the triangles will have the same area because they were replicas of each other. So that means each triangle should have an area of half base into height. So this is how we derive the formula half base into height. Let's look at some specific properties of right angle triangle. A right angle triangle, as we saw, was a triangle which has 90 degree, one angle is 90 degree, right? A scalene right angle triangle, the triangle is right angle, so one angle has to be 90 degrees, and the triangle is also scalene in the sense that none of the sides are equal. So this is a type of triangle we are talking about. The second type of right angle triangle is isosceles right angle triangle. Now it is right angle triangle, so it has to be, one angle has to be 90 degrees, right? Then it is also isosceles, so that means two sides will have to be equal. Now you will see that these two sides will always be these two sides. We cannot have, let's say this is right angle triangle, we cannot have this side equal to this side. Why can't we have this side equal to this side? Because if we had it, then because the sides are equal, their opposite angles are also going to be equal. So that means this angle is going to be equal to this angle. This angle is going to be equal to this angle. And what is the measure of this angle? This is 90 degrees. So this angle will also have to be 90 degrees. Now if both of these are 90 degrees, the sum of which is 180, so that means this angle will have to be 0 degrees, because the sum of all angle has to be 180 degrees. So 0 degree angle does not make, 0 degree angle is basically a line. So then again you will see that these 3 points become collinear, and basically 0 degree angle in a triangle does not exist. So this condition is not possible. So that means if it is a right angle triangle and two sides are equal, then those will have to be the sides that are making that right angle triangle, correct? And then also their angles are going to be 45 degrees. And why is that going to be 45 degrees? That is because if this side is equal to this side, then this angle is going to be equal to this angle. So let's say that is x. So x plus 90 is 180 degree. So x will have to be 45. So let's look at one of the most important theorems on the GRE, that is Pythagorean theorem. So what does it say? It says that in a right angle triangle, so we have a right angle triangle here, ABC. In a right angle triangle, see this is considered as base. This is considered one side. This is considered another side. This is the third side, and the longest side, or rather the side that is opposite to this 90 degree, this is called hypotenuse. So the Pythagorean theorem says that a square plus b square, the sides that are constituting the right angle. So a square plus b square, sum of these two adjacent sides is equal to the square of hypotenuse. A square plus b square is equal to c square. This is one of the most fundamental theorems in geometry, and we'll quickly look at one of the proofs. It has over 100 proofs. We'll just look at one of them for the sake of simplicity. So Pythagorean theorem, let's do another construction the way we did last time. Let's look at a triangle, right angle triangle like this, and let's say this small side is A, this relatively longer side is B, and the hypotenuse is C, right? So make a paper cutting like this, ABC, and make around, I think, 7-8 of such triangles of the same size. Okay, arrange them in a way that is shown in figure 1. So let's say we have this one triangle like this, we fit another triangle like this, third triangle like this here, and the fourth triangle here, and the remaining we put a paper square. This is a square of side A, this is the square of side B. correct? So you will see that the entire figure, the big figure, the uh, big figure is going to have is also going to be a square, side of which is going to be a plus b, right? So this is figure 1. Same thing we do with similar thing we do in figure 2. We take 4 triangles ABC and we try to fit them in such a way, and we'll also fit a square of side C in the middle, right? So you will see that both these squares are of the same size. That means their areas will have to match. Now what is going to be the area of this square? How many triangles we have? Small triangles we have 1, 2, 3, 4. We have 4 small triangles ABC. So this is 4 into area of each triangle, which is half AB, right? The area of this is going to be half base into height. Height is something that is perpendicular to the base. So this height is A here. So half A plus 4 times half AB plus area of this small square, area of this big square, plus A square plus B square. This is the area of the whole larger big square from figure 1. The area of the larger big square from figure 2 is 4 small triangles. So it's going to be 4 times half AB, and inside the square is of side C, so it's going to be C square, right? So 4 half AB plus C square. You will see that 4 half AB is constant in both, so we'll just take them out, right? What remains is A square plus B square is equal to C square. So this is one of the proofs of Pythagorean theorem. You don't really need to know the proof for the sake of the GRE, but it is it is good for your understanding. All you need to know for the exam would be A square plus B square is equal to C square. Okay, Pythagorean triplets. So triplets are sets of 3 numbers that follow the Pythagorean theorem. For example, if you talk about a triplet is ABC, it means C square is equal to A square plus B square. As simple as that. So there are some basic triplets that you need to know: 3, 4, 5, and any of its multiples, or for that matter, a multiple of a triplet is also going to be a triplet. So 3, 4, 5 and its multiple like 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25, 20, 21, 29. Now why you need to know this is that because a lot of times you will see that you have a right angle triangle and two of the sides are given. So if they have, like for example here 3 and 4, if you know the triplet that 3, 4 and 5 is a triplet, you can immediately find out the length of this one. Even otherwise, what you can do is you can square this, which is 9, you can square this, which is 16, you can add them up, you get 25, you take a root of that, you get 5. But with big numbers, it is going to be time consuming. So it is always good if you know the triplets, and a lot of times you will see that these triplets are very helpful in quickly solving the GRE problems. So special triangles, isosceles right angle triangle, we just looked at that in one of the earlier slides. So we are talking about a triangle that is isosceles. It is right angle and it is isosceles. So it is isosceles right angle, so it has to be, these two angles have to match. This is 90 degrees, this is going to be 45 degrees, this is going to be 45 degrees, right? And the sides, one important thing you have to remember is sides are in ratio 1:1 √2. So let's say this is 1, so this side and this side are same in length, so this is going to be 1 unit again, and this hypotenuse is going to be C square is equal to A square plus B square, right? So A square here is 1 square 1 plus 1 square 1, so 1 plus 1 is 2, so this length will have to be √2, correct? So the sides are always in the ratio 1:1 √2 will be the hypotenuse, right? This is another type of special triangle that always that has interesting properties and always comes on the GRE. It is 30-30-60 degree triangle. So the 30-30-60 degree triangle, the sides are in the ratio 1:√3:2. Okay, let's say let's look at this. This is 30 degrees, this 90 degrees. Oh, I'm sorry, this has to be 30, 90, 60. It's 30, 90, 60. Right, so this is 190 degrees, one angle is 30 degrees, the other angle will have to be 60 degrees, right? And you will see that the sides are in ratio 1 is to root 3 is to 2. Now why is that? Again, we can help get help from Pythagoras the theorem. This side that is opposite to the smallest angle is going to be the smallest side, so that is going to be x. The hypotenuse is going to be twice of that side, which is 2x, and the remaining side, which is opposite of 60 degree, is going to be x root 3. And how can we verify this? We'll just use Pythagoras theorem. We'll say this square plus this square is going to be this square, so we get x square plus this square is going to be 3x square, right? Root 3x, the square of root 3x is 3x square, so x square plus 3x square is going to be 4x square, root of which is 2x. These are very important properties, you have to know them, otherwise you will spend a lot of time doing very standard type of calculations. So it is always recommended that you know these ratios. Let's now jump to the practice problems. This is the first practice problem for you. You can give it a try. Okay, let's see how to go about this. From his home, Rob travels 10 miles west, 6 miles north and 4 miles west again. How far is he from his home? Okay, so let's say he started from here. Let's say his home is here. This is one point. Rob travels 10 miles west. So west is going to be this way. So 10 miles. Then 10 miles, 6 miles north. So this is going to be 6 miles north. Right? So get this correct. This is how the directions look. Don't get confused. Okay, so this is 6 miles north and 4 miles west again. So this is 4 miles west. So they are asking how far is he from his home. So his home is this way, and they are basically asking this particular distance. So if you redraw this, let's look at this particular, let's extend it. We are looking at, let's say, this particular triangle. Okay, how far is going to be the height of this? The height is going to be 6, right? Because this is going to be equal to this, and the base is going to be 14. Why? Because this much is 10 and this 4 when comes on top, so this length is also equal to 4. So we are basically talking about a triangle which one side 16, right angle triangle, this side 14, and they are asking us about the hypotenuse. So using Pythagoras theorem, so let's say hypotenuse is c, we get c square is equal to 6 square plus 14 square, right? So that is equal to 196 plus 36, correct? So that is 232. So c is going to be root 232, which is 15.32 miles. You can do it on the calculator. So this is going to be 15.32 miles, and they use Pythagoras theorem to solve this. Let's move to the second problem. Quantitative comparisons. You can try them. Okay. The sides of triangle are x, 6 and 8. Okay. So what can we say about x, 6 and 8 if you know the sides of triangle are? We have a rule, right? We just looked at it. Any particular side of a triangle cannot be greater than the sum and cannot be smaller than the difference of the other two sides, right? So x will have to be smaller than 14 and x will have to be greater than 2 and not equal to. X cannot be equal to 2, x cannot be equal to 14. It has to be less than 14, it has to be greater than 2, correct? So the quantitative comparisons are very straightforward from here. We are being asked to compare x and 2. So we know that x is going to be greater than 2. So answer here is A. X and 14, we know that x is going to be less than 14. So answer is going to be B. Let's move to the third problem. Try to solve it. Okay, in square ABCE, so we have this figure. We see that CED is a triangle. It happens to be an equilateral triangle because all the three angles are same, 60 degrees, and this is given to be a square. So that means all these angles are going to be 90 degrees. Okay, so in square ABCE, because it's a square, the side of all the four sides of this are going to be same. So all are going to be, let's say, x, and x is also going to be the side of equilateral triangle, right? So in square ABCE, diagonal AC, so we're talking about this line now, diagonal AC is 5 root 2. What is the perimeter of triangle CED? Okay, so again we have to use Pythagoras theorem here. Let's look at this triangle A, E and C in detail. So we are talking about this triangle A, E and C. We know this side is going to be 90 degrees, right? This side is x, this side is x. So what is going to be this particular side? The diagonal of the square is always going to be root 2x, right? Why? Because this is 45, 45, 90 triangle. These two sides are same. So it's going to be root 2x, but it is already given to us actually. So we know that root 2x is equal to 5 root 2. So that means x, which is side of the square, which is also the side of the equilateral triangle, is going to be 5 units. Okay. So what is the perimeter of this triangle CED? CED is going to be x plus x plus x. It's going to be 3x, right? So 3x is going to be 15. So perimeter of this particular triangle is going to be 15 units. So let's move to the next problem, quantitative comparison. You can give it a try. The area of triangle ABC, okay, ABC, it happens to be a right angle triangle, okay. Area of triangle ABC is 100 square units. Okay, so what can we say? And we also have some numbers given here. Okay, so let's say this height, let's say okay, and even before that, let's look at what is being asked. AD, so we are required AD, we'll have to find out its value. We'll also have to find out the value of DB. So let's say AD is equal to x, B, and B DB is going to be y. So the whole length becomes x plus y. Okay, and what do we know about the triangle? The area of triangle we know. Area of which triangle? ABC. So what is the formula for area of this triangle? Half into BC, which is the base, which is 8, into the height. Height is x plus y. X plus y. Half 8x plus y is equal to 100, right? So that means 4x plus y is equal to 100. So that means x plus y is equal to 25. Correct? So x plus y is equal to 25. This is going to be 25 feet, whatever, 25, yeah, 25 units tall. It's going to be 25 units tall. Okay, interestingly, this height is also 25. Sorry, this length is also 25. This particular length we are talking about. Okay, let's see if that is useful or not. Because if it was x is equal to 25, then we could conclude that this triangle ADC is isosceles. But here, this 25 and this 25 are not really related, because we are talking about this line and this line, and these lines are not part of the same triangle. Correct. So it's just a coincidence probably that both these lengths are 25. Okay. Anyway, let's see. So we now have to find out AD individually x and individually y. Right. Okay. Now let's look at this one. This triangle D, B and C. So DBC is again a right angle triangle. So we can also apply Pythagoras there, right? So what does it mean? It means that y square plus 8 square, correct? This is the base of this triangle, is going to be equal to hypotenuse square, which is 25 square, correct? So fairly straightforward now. So y square is going to be 25 square, which is 625, minus 8 square, which is 64. So y is going to be root of 561. Okay. And so we know this quantity now, y, that is dB, so we know this quantity. We just have to compare this quantity with AD, right? Okay, now let's look at this. AD is x, which is going to be 25 minus y, correct? So x is going to be 25 minus y, which is going to be 25 minus root of 561, right? We don't really need to calculate this value because root of 561 is going to be close to 23. So this value is going to be close to 2 or some, right? So something close to 1 point something, right? And all we have to do is to compare AD, which is 1 point something, and DB, and DB we already know it is going to be something close to 23. So we can say that, safely say that this value is smaller than this value, and the answer is B. Let's look at this problem now. Please try to do it on your own. So if Jack takes path A and path B to reach point Z from point X, so Jack, how is he going? He is going from X to Z like this, path A and then path B, okay? And Jill takes path C, so Jill takes path C. How many miles does Jack walk longer than Jill if path A is 3 miles long? Okay, this is 3 miles long, and path C is 5 miles long. Okay, pretty straightforward. So we know this is a this is a right angle triangle. So using Pythagoras theorem, what we can say is this guy, part B, is going to be 4 miles long. We can also use Pythagoras triplet 3, 4, 5, or you can do 5 square minus 9 square under root. So that is 25 minus 16. 25 minus 9 under root 16 under root 4. So this is how we can find out the value of path B. Now, how long does this guy walk? Jack walks for path A plus path B, so that means he walks for 7 miles. Jill walks for 5 miles. So that means Jack walks 2 miles longer. Let's look at this one. Okay, Brenda is standing 50 feet away from a skyscraper. Okay, let's draw a skyscraper for, let's say this is a skyscraper. Okay, Brenda is standing 50 feet away from a skyscraper. Okay, so let's say she's standing somewhere here, and this is 50 feet. Brenda is standing 50 feet away from a skyscraper. When she looks at the top of the building, her eyes make an angle of 45 degrees with the ground. Okay, so this angle is 45 degrees. Now wherever you hear 45, obviously this is 90, right? Because it's the angle building makes with the ground, so it's 90 degrees. So this is 45, so this also has to be 45, right? So if this is 45 and this is 45, and this distance is 50, so that means the height of the building will also be 50 feet. Correct? This is information that we get from the first statement. When she looks at the top of the building, her eyes make an angle of 45 degrees with the ground. She moves some distance away. Now this is very important. It is away. Okay, so let's say she goes x feet further. So now she's standing at 50 plus x feet. She moves some distance away from the building, and now her eyes make an angle of 30 degrees. Okay, now this angle, obviously because she's going away, this angle is going to be smaller, right? So this angle now is smaller, it has reduced from 45 degrees, so it has reduced to 30 degrees. Okay, so look at this angle now. Look at this triangle, this is 30 degrees, this base is x plus 50, this height is 50, correct? And this is a 30 60 90 triangle. So there is some ratio that we can find out, correct? When she looks at the top of the building, okay, how much did Brenda move? Now we have to basically find out value of x. Now we know that these angles, sorry, these sides are in the ratio 1 is to root 3. That much we know, right? Because it's a 30 60 90 triangle. So we know that 50 divided by x plus 50 is in the ratio 1 is to root 3, correct? So what do we get? We get x plus 50 is equal to root 350, correct? So that means x is equal to root 3 minus 1 times 50, correct? So if we do that calculation, we will get that x is going to be equal to 36.6 feet. So this distance she moved away was 36.6 feet. So that brings us to the end of this session. I hope you enjoyed the session, and I look forward to meeting you in the next session. Thank you.